Um, Welcome everyone. Let me quickly share my screen. Here we go. Okay, hopefully that should work. Yes, welcome to the Developing the PID Graph Implementations by the FREYA Project and Beyond session. My name is Artemis. I work at the European Organization for Nuclear Research and I represent the FREYA project here today. This session includes 5 talks and a Q&A. And before that, I will give a brief introduction, including some background information. Okay, you know the drill with these rules. We're recording this. Please stay muted and please add any questions you might have in the chat. And there is a Q&A at the end of the session. So first things first, you may have read in the session's abstract that we are going to be talking about practical applications of the PID graph concept. Yesterday, there was an entire session dedicated to PID graph services, but in case there are people that did not attend or are not familiar with the PID graph, I will give a very brief introduction to some terms that will be relevant for this session and talk a bit about some of our work in FREYA. So the PID graph refers to a conceptual model that describes resources identified by persistent identifiers and the connections between them. And in FREYA, we have been calling this a network of interconnected PID systems, which links PIDs together via relations in their metadata to enable the discovery of connections in a way that both humans and machines can follow. So in order to take advantage of the PID graph, FREYA partners have developed tools that can be used to make queries to discover PID connections that may require some more, let's say, advanced searching. FREYA has launched various tools, primarily through the collaboration of the PID service providers, DataCite, Crossref, and ORCID, who are FREYA partners. One of them is DataCite's GraphQL API. I don't know if everyone knows what GraphQL is. So it is an open source data query language for APIs, which allows us to make queries across a graph of interconnected objects. It is possible to query the GraphQL API for various resources currently, including DOIs from both DataCite and Crossref, researchers using the ORCID API, funders using the Crossref Funder API, and organizations using the ROAR API. An extension of this GraphQL API work is the development of a series of Jupyter notebooks. Jupyter notebooks are computational notebooks which allow us to create documents that contain various things from text to equations to live code, etc. And since they easily integrate with the GraphQL query interface, we have used them as a way of addressing various PID graph user stories, which we have identified in the FREYA project. So while we might have used them for specific user stories, the notebooks can be easily reused by using different PIDs or queries as input parameters. And so some examples of user stories are, say you're a software author and you want to be able to see the citations of your software aggregated across all versions, or you're a funder and you would like to be able to find all the outputs for the grants you have awarded. So user stories, these are a few examples of those. And finally, another PID graph tool that was developed through FREYA is the Common DOI Search Service, which, well, more correctly called the DataCite Commons. That is a web interface for querying the PID graph. The service currently allows the discovery of content registered with the DOI, primarily from Crossref and DataSite in a single search interface. It also supports searching for people, research organizations, and funders using the ORCID and ROR services, respectively. Now, moving on to enriching the PID graph, one of the main tasks in FREYA has been, for FREYA disciplinary partners, has been piloting new or emerging PID types in their services. And in 2018, FREYA carried out an assessment of the landscape of established and emerging persistent identifiers used in scholarly research. For that work, partners decided on specific prototype services that could be taken forward based on the maturity level, primarily of each identified new PID type. And as a result, a lot of attention has been given to PIDs for organizations with a focus on ROR IDs, grant identifiers, and instrument identifiers. And we have a talk about instrument identifiers in just a bit. And I should also note here that the global grant identifier system is only beginning to be adopted, and that all funders need to consider using DOIs for grants if it's going to move forward. Now, having finished this work, there are a couple of important lessons learned that should be highlighted here. One of is a bit negative, but I think it is primarily due to the nature of new infrastructures or initiatives in general. And that is that they tend to be accompanied by issues that still may not have been resolved. Of course, this is rarely a problem for mature services and tools for obvious reasons. So at the same time, though, we have also been able to ascertain that while FREYA partners represent various disciplinary communities, the multidisciplinary aspect did not actually pose any problems, and all communities involved were able to benefit from adopting new PID types, which is very positive. So next thing I'd like to touch on is the theme of this session, which is applications of the PID graph concept. There can be a wide range of possible applications for the PID graph, but in FREYA, our main focus has been on disciplinary applications, that is, integrating the PID graph concept into community services for the benefit of the communities they serve. So FREYA partners have integrated PID functionality in various ways in production services in social sciences, life sciences, high energy physics, etc. And if I could give you some examples of this, of these integrations, it could be mature PIDs, so that would be for publications or people, better article data and software linking through PIDs, improved workflows for data and software citation, also richer metadata, so provenance information, schema.org, etc. When we are looking to integrate the PID graph concept in community services, we can distinguish two separate aspects of this. We can have communities that adopt the PID graph tools that I have mentioned to enhance the services. On the other hand, services may also develop their own graphs. And by that, I mean any local graph of interconnected PIDs that supports a particular service. And these local graphs can be thought of as subgraphs, which can be exposed to fit into the broader PID graph of the research landscape. And one could imagine the local subgraphs as puzzle pieces which connect to the broader graph and feed additional information into it. I've included some links here for everyone. If you're interested in any of the things I mentioned, you can have a look later. I will upload my slides, of course. And having said all that, FREYA's goal as far as this work is concerned has been to demonstrate how the PID graph can be implemented in community services and how communities can be incentivized to discover and exploit the content of the PID graph. And to provide some more concrete examples, we have 5 talks in this session, 3 by FREYA disciplinary partners, then a talk by one of our FREYA ambassadors, and finally a talk about the open air research graph, which is closely related to our PID graph work in FREYA. And at the end, we will have a general Q&A. So that's all for the introduction. So now I'm going to ask my colleague, Christine Ferguson, to get us started with the first talk. And I believe I have your slides, so let me open that up. Here we go. Okay, over to you. You need to unmute, Christine.
All right. Hi there, everybody. I'm joining you from Cambridge in the UK today. And next slide. I'm going to talk to you about work we've been doing on Europe PMC. Next slide. Oh, yeah, thank you. I work on the team that runs Europe PMC. It's an open and free literature database developed by EMBL EBI in partnership with PubMed Central in the USA. It's a very large resource, but I'll touch on the numbers of records that you can see on the slide in a bit. But in terms of sustainability, it's been running since 2007, initially known as UK PMC, and then from 2012 was known as Europe PMC. Next slide. So Europe PMC is a repository of choice for 31 international funders, and you can see here some well-known names, the ERC, the Wellcome Trust, UKRI. Next slide. So Europe PMC's core content is biomedical publications. And so what I'm going to present to you today is one of those subgraphs that Artemis referred to earlier. It's our local PID graph, which is literature-centric. We work to enrich biomedical records by connecting them to other research resources. Europe PMC indexes 37 million abstracts and more than 6 million full text articles. And the records here have been enriched by providing links to 103 million data sets. So you can see those data related icons in the top left quadrant. 1.5 million researcher or ORCID IDs for researchers, and more than 8 million funding acknowledgements. So that's bottom right. Next slide, please. We've worked to extend the literature-centric graph, and I'll tell you about 3 ways we've done this today. Firstly, we extended the core content by adding preprints. So preprints are manuscripts that are shared online before the completion of a journal organized peer review. They can be considered to be a precursor version of a formal journal article, but have their own unique DOIs. And in the same way as journal articles, we link them to ORCID IDs, data records, grant information. And notably, where a peer-reviewed journal article version is available, then the preprint is linked to it in Europe PMC. So by indexing these preprints, the entry points into Europe PMC's graph are increased in number. Next slide, please. A quirk about preprints is that they have versions. So a preprint can have up to 19 versions, we've discovered. And by capturing the version information, linking versions to each other and to the final journal article, if it exists, and exposing this versioning information to users, we provide multiple entry points to the PID graph. Next slide, please. In addition to increasing the core content, we've linked to more resources using their persistent identifiers. So in the diagram on the left, you can see where mature persistent identifiers have been used, and we've worked to include persistent identifiers for 2 emerging PID graph resource types, organizations and grants. So let's start with grant identifiers. So as many of you know, funders assign an internal grant identifier to the grants that they award. So these are very specific to the funder, and they don't necessarily map across other funders. And there's been recognition in recent years that this system, where every funder devises its own set of internal identifiers, this isn't ideal. So recently, or in recent years, a group of stakeholders, including Europe PMC, have proposed to use DOIs in a global grant identifier system. Next slide, please. The benefits of switching to DOIs are outlined here and include disambiguation, so to avoid internal identifier overlap between funders. We've definitely found grants that map to different funders using the same identifier. Other benefits are citability, automation, usability. DOIs redirect to a website with information, and we're able to link these into an existing PID ecosystem that already contain DOIs. Next slide, please. So how will this work? As a first step, a funder needs to join Crossref as a member to register DOIs for their grants. A typical grant DOI is outlined here in white. It would have a prefix that is unique to the funder, which is in red here, and a suffix that is unique to the grant. So you can see that here in blue. The DOI would lead to machine readable information, which is created by the funders, and this is the Crossref compatible metadata containing grant information. The DOI would also lead to a person readable record, and here the funders need to provide an openly accessible online resource that the DOI directs to. So how is Europe PMC involved in this? Well, Europe PMC handles steps 2 and 3 for its funders. So for step 2, it produces the XML files containing grant metadata to send to Crossref. And for step 3, Europe PMC already hosts and maintains a grants database that stores grants data from each of its 31 funders. Next slide. The Grant Finder, as you can see here, is a tool that can be found on Europe PMC's website. And it is the site that will provide the landing pages for grant DOI redirection. You can see it has one section for Europe PMC funder grants on the left. And on the right, the panel on the right, you can see there's the ability to search by different fields. So you can search by PI, their ORCID ID, or their institution. You can search by the funder or the grant ID or by keyword. So in 2019, only last year, Europe PMC began to incorporate DOIs for welcome awarded grants held in the database. So the question becomes, how do you link grant DOIs to publications? Next slide, please. Ideally, publishers would incorporate adding this information into their submission workflows. But as a proof of concept, this is still very early days, Europe PMC worked with PLOS and the Wellcome Trust, and this formed part of the work we undertook as FREYA partners. So in this example, what you can see here are, on the left, grant DOI hyperlinks. I hope you can see that in a +1 article. And these lead the reader to grant information, which is in the grants database in Europe PMC. So on the right is the landing page for the lower welcome grant that includes grant titles, dates, the PI, the DOI, the original local internal identifier used by Wellcome, etc. But importantly, the page also features research outputs from the same grant. So other publications that have been funded by this grant, and those are marked in a red box. So this is how grants are linked to the ecosystem of identifiers making up Europe PMC's local PID graph. Next slide, please. So please consider how this demonstrator can work for you. But for it to work as a global solution, it will require that funders register with Crossref. Researchers include grant DOIs in funding statements, publishers insert these into their workflows and article metadata, and they're used by research managers and repositories. Next slide, please. The situation with incorporating organization identifiers is a little different to global grant identifiers. So this is I'm quickly going to take you through this. At the start, we had no organization identifiers in Europe PMC, no space in article metadata to include organization IDs. So affiliations were captured by basically free text strings. And these free text strings varied in granularity. Some captured departments or units like the gastroenterology unit. Some only captured the institution. Some of the institutions were captured in languages other than English. For example, some of the French institutions like the CNRS. Other times they're included in articles by the English names. So the French National Center for Scientific Research wouldn't ring many bells. So our aim is to map raw IDs to existing records in Europe PMC, but given the complications, how are we going to do this? Next slide, please. We started really small and planned an integration that would address a user story. And that user story was the following. So as the EMBL EBI communication team, I want to unambiguously identify research outputs for EMBL EBI for a particular year so that I can feed this into our annual report or feed it back to funders, etc. Next slide, please. So we set about mapping the raw IDs for EMBL EBI to publications that have EMBL EBI authors. And jumping straight to the integration we achieved, you can see on the left the raw record for EMBL EBI. And on the right, when you search, this is a snapshot of the website of one of our web pages. So if you search Europe PMC for articles authored unambiguously by EMBL EBI researchers, it returns more than 1,000 results. The publications can be divided up into years by having a look at the, by checking the boxes on the left in the blue box. So in this way, we're able to address the use case for EMBL EBI communications team. Next slide, please. So the lessons learned are, I haven't really got a lot of time to go through these, but it was really difficult to add raw IDs retrospectively to text strings. It was very time consuming. And the key thing we found was, you may have noticed from the raw record in the previous slide, it didn't have any geolocation information barring the country. So as soon as you include the town or the city that the organization exists in, we were able to then use a machine learning algorithm in combination with the raw API, which is provided by the community, and found that this approach can predict correct raw ID even for a misspelt affiliation in a text string. It can't process small affiliations, like I mentioned previously, the gastroenterology, I can't pronounce that, but when they mentioned by unit, and but they can process text strings from publications that have DOIs and PubMed IDs. So we've not made this public yet, not been able to, but we have been able to assign match raw IDs to upwards of 40,000 DOIs submitted to us by a partner in FREYA. So finally, just to summarize, next slide, we've managed to extend the PID graph by linking in core content and providing multiple entry points into our PID graph, as well as adding in small integrations for emerging PIDs. And finally, I'd like to thank the Europe PMC funders and the European Commission for their support for Europe PMC's part of this work. Next slide. I'd be happy to take questions at the end.
Okay, thank you very much, Christine. So next up is Manuel. So please go ahead.
Hi, so my name is Manuel. I'm the project and technical lead for Identifiers at EMBL EBI, and we're going to talk in this presentation about what it means connecting life sciences data and how we are doing it. The EBI is at the heart of biological data services, research and training in Europe. It's part of the European Molecular Biology Lab, which is an intergovernmental research organization with staff members from more than 60 different nationalities. It's also the home for the Elixir Technical Hub. So being a trusted data provider for life sciences, we realized that a single sequencing or proteomics experiment can produce terabytes of data. And all this data that is being dealt with and is being produced and consumed in life sciences, it is done so in silos, and it's massive. So it's becoming difficult. It's becoming difficult to reach, because there are every data resource, every data provider has its own data access schemes and different mechanisms to reach out to that data. From identifiers.org, we develop a platform around the idea of a compact identifier. So every data resource will identify uniquely those data sets by a locally unique ID, but they are not interoperable between different data resources. So in identifiers.org, we create like a wrap-up context. We call it a namespace. And within this context, we collect one or more data providers related to that ID space. It could be taxonomies, for example, or it could be about proteins, like the data provided by Unipro. It could be protein data bank structures, like the data provided by PDB. And by this combination of this wrap-up context, which we call prefix, and that locally unique ID, which is the accession number, we come up with a persistent globally unique ID that is interoperable. So it provides a uniform mechanism to go from what you see on this slide, that is the different particular data access scheme from the different data resources, into a uniform way of citing data in life sciences. There are nowadays a few journals that are already on board with this mechanism, and it makes it really easy for data producers and data consumers to talk about the same data sets and to share their data sets. So it's a verification mechanism. How do you work with compact identifiers? So you work through two main services that are provided by identifiers.org. One is the resolution services, and this is the service that will take your compact identifier and link you to the final data provider that holds the information on what that globally unique ID is referring to. And the other one is the RAID-C service that collects all that metadata, all that information of the different namespaces, those different contexts where we had different data providers. And this is the main mission of identifiers.org, to provide persistent identifiers and services to enable the consistent access to biomedical data. It integrates in infrastructure as a service provider listed in EOS Hubs, the EOS Marketplace, and it's a recommended interoperability resource from Elixir. Now, how do we tap into the PID graph? In the case of identifiers.org, we work with many different kinds of IDs, with many different kinds of accessions, which are already part of that PID graph that we're talking about in this session. But we have an additional mechanism that we have implemented in our infrastructure to tap into the PID graph from the point of view of organizational IDs. And we do that through an integration with RAW API, using RAW as a provider of organizational data. I hope that gave you an overview of identifiers.org verification mechanism, and thanks a lot for listening to the presentation.
Thank you very much, Manuel. And moving on to Tina.
Is it already showing full screen?
It's showing, but not full screen.
Full screen. Okay. Not sure. Okay. Is that better?
Yes.
Okay. So hello, my name is Tina Dona. Oh, this is the last slide. This is we'll start from the beginning. My name is Tina Dona. I work for Pangea at the University of Bremen. I'll be talking about the instrument PIDs, which are emerging PIDs in a way since they've just recently sort of come into action. And I was going to talk a lot about the work of the RDA interest group around this, the PID-INS group, but there was a very nice presentation yesterday summarizing all of that. I had to sort of change the angle a little bit, and I thought I'd take you through the sort of workflow that we took in, or the process that we went through in FREYA to mature some of these PIDs, or to implement them and build tools around them, around this instrument PID for Pangea and an associated institute. So Pangea is we're a data publisher for Earth and environmental research data. I think one can say now it's an international data publisher. We host a lot of data sets and even more individual measurements in these data sets. And I think this is probably an outdated number. With so many months of home office, we've had a lot of data submissions of people catching up from the last 10 years or so. So we started out as an institutional repository for the Alfred Wegener Institute, and are now permanently funded through the Marum and Alfred Wegener Institute in our own right. So laid out to be a permanent facility, guaranteeing this long-term availability and accessibility of archive data. It's for Trust Seal certified repository, and we're open to any project, institute, or individual scientist who wants to archive or publish their data. So the FREYA consortium strategy is something that Artemis already touched on a little bit. Is when you look at the consortium partners, you can see that we've sort of tried to assemble data publishers, research institutes, and PID providers all in one consortium, so that we could sort of follow through the whole cycle of a PID coming into its own right. So that was the strategic partnership around these PIDs, which I think to many degrees has worked very well. And we started out doing a landscaping analysis to sort of find out which PIDs were emerging, which ones were mature, what could we do, and such. And so this is sort of the first step. And one of the PIDs that came up was around, we called it then equipment, to sort of be more encompassing. The instrument PIDs was an emerging PID through this RDA interest groups work also. So Pangea and STFC, which is also a partner on FREYA, joined the group, and we provided some use case. We provided a use case each to this group. What we were trying to do in the sort of in our FREYA vision is to figure out if in a perfect world, how many dots could we connect? And we did this by with these user stories that Artemis also mentioned. And around instruments, it was things like a researcher would like to find and evaluate related data to an instrument, or a facility wants to know if the instrument has great impact in research, or find data from other data from the same instrument. So this was the approach we took. So we're trying to make as many connections as possible to answer to as many user stories as possible. So in the RDA working group, I'll just summarize it really quickly. They had, because it was there was a detailed talk about it. So they had a very large collection of use cases from many disciplines, which was very helpful since the way instruments are deployed, used, and assembled and such is so different from discipline to discipline. And some of the instruments are federated networks in marine science, for example, they're often just screwed together on the ship and then thrown in. They're very different ways of dealing with instruments. So that I think that was a very good approach to take to get as many use cases as possible. There was a public feedback period via the GitHub on the metadata schema that was developed as part of the group, and members of the group also became early adopters. So there were two related use cases. The AVI is the Alfred Wegener Institute, one of the institutes that funds Pangea, and they have a framework for sensor data flow to archive. So this observation to archive framework. And within this, as a building block, is Sensor AVI, which is a sensor registry. And it also includes information on sensor status, on deployments and such. And they currently use a handle system for their sensors. So whenever a sensor is deployed, it gets this handle, and with it, this also comes the provenance information of what happens then, what other sensors is it combined with, things like this. And this the data is then commonly published in Pangea. And they want to follow in the future the metadata schema proposed by the PIDs group, and move from these internally minted handles to DOIs, which has not happened. So I'm just taking you through the workflow to the point where they have gotten to, or we have, and then needed solutions for versioning of sensors. So when sensors have certain parts exchanged, things like that, is it a new sensor? And Pangea is the data publisher for the data coming from this O2A workflow. And so our focus is on FAIR data for users. And so the data is archived in a relational database, and we use standard terminologies for parameters, methods, and such, or we want to rather. The data is published and registered with DOIs. And there are APIs available for advanced interactions. So the use case focus was that we wanted to include PIDs for instrument as part of our metadata to enrich the metadata and make it more fair for reuse, most importantly. And then part of the problem was to remove the ambiguity between the methods and devices, which in our database was a mix of things for various reasons, and wanted to link these instrument PIDs to the PID graph architecture in FREYA to make these connections that I showed earlier. So this is the workflow from the O to A. Just wanted to show it. So the data acquisition is at the very beginning, and then comes the sensor management platform, and we are at the very end for data publications. And this is such a page for landing page for a data publication, or the splash page. In here, we have the link to the handle for the instrument used in this research. We have another descriptor device called device with our own terminology in it, which is currently still somewhat separate from the AVI terminology. and through the handle, you're then redirected to sensor AVI, where you get a lot of information about this this sensor itself and the description of the sensor and who's responsible for it and where it is and if it's deployed or not and things like this. So the common goal was to enhance the quality of published and archived data in Pangea by providing this complete metadata for the instruments and sensors that was used in the sampling. So the current use was this handle system that I described from Sensor AVI. They have some there's some problems with aligning how they have been doing their sensor registration with what is suggested by the schema. And so that there's work to sort of align these two. There's so currently we can we include when this is possible the handle for in the data set. So and in the future they want to use a DOI concurrently with the handle system they still have. So all parent items, so parent platform basically is placed in a live archive with its children, and these then are automatically linked also to DOI registration. There's still work for the crosswalk for the sensor ML schema that's being used and the PID-inst RDA schema. And one of the important things also is these controlled vocabularies that that need to be defined to describe these type of objects. There's ROR identifiers have been included in the metadata now, on a small scale, and once we have gone through cleaning up the whole ROR mapping to Pangea organization registry, then we will include a lot more. So we're still working on optimizing the workflow from the sensor AVI to Pangea. So that's also even more work. So if we, let's say we query a DOI for an instrument, this is from HZG, I think, Lynn, an instrument that they've registered to with the DataCite, and we used our GraphQL from DataCite, then we get the ROR for the institute that houses this instrument, and also the link to the description of this instrument. So we were already quite far in terms of this this graph that we're trying to complete, and inside Pangea we have a lot of this connections of linking instruments to the researchers through their ORCID in the dataset metadata. We link it to the data, to publications associated with the data, which is also part of the metadata, and with organizations which coordinate the projects that the data came out of. So DataCite is also working on improving this connectivity with instrument PIDs, and this will gain traction as more people start registering instruments. And as I think as a lessons learned from this whole process is obvious that instrument metadata or instrument information is critical for data reuse. So this is a really important step in making a high quality reusable data. And FAIR aspects of metadata, like these vocabularies that we're struggling with in an afterthought, trying to align everything, is very difficult. So it'd be beneficial, would be centrally managed and cross-disciplinary. PIDs group also worked. And EOS could provide a service to sustainably manage instrument metadata and provenance information to sort of avoid these local, often unsustainable. Yeah, and that is the end of my talk. I know I went a little bit over time. I'm sorry.
Thank you very much, Tina. So next up is Luke Peruta from Duncan. So Luke is one of our ambassadors, and yeah, look forward to your talk. Go ahead.
I'll assume you can see my screen if you can't. So hi everyone, I'm Luke. I'm one half of Duncan. We're a small nonprofit based in France. We often describe ourselves as not only data scientists, but also science dataists. Like Artemis said, I'm one of the ambassador of the FREYA project, and today I'm going to talk about Cobaltmetrics, the PID graph, the relation between the two, and I'll try to introduce the concept of fairness debt and how we can pay that off collectively. Yes. So our main project is called Cobaltmetrics. We've been described as the new kid on the block of altmetrics. We make altmetrics genuinely alternative by supporting more than 300 different natural languages and more than 60 types of identifiers and persistent identifiers. Not all the identifiers that we support are persistent, and that's kind of the point of this talk. There are two complementary services in Cobaltmetrics. One is the citation index, which is similar to altmetric plum cross-reference data, and we're not going to talk about this today. But the other service is called the URI transmutation API, and if the term is new to you, I'm going to explain exactly what that is. So once upon a time in FAIRyland, and I love the FAIR acronym, by the way, there are so many ways to build upon that. Many initiatives like FREYA, FAIR's FAIR, and I guess pretty much anyone who's joining this conference advocates the adoption of PIDs for all kinds of scholarly entities, and we wholeheartedly support that, we really do. But in the meantime, until PIDs become the default, and until PIDs become the only type of identifier, even though that will never exist, one of our missions is to ensure that entities that were not blessed with PIDs or that were not cited with PIDs can still be linked with the rest of the scholarly graph. And so we hear about FAIR this, FAIR that. I'm sorry, it's really slow to switch between slides. FAIR this, FAIR that, and I often roll my eyes because it's very nice on paper, but I think we can do more. So I'm going to play a very short video from the movie Miscongeniality. You don't really care about the audio, but I've added subtitles that exemplify how I feel about FAIR data.
I would have to say world peace. Definitely world peace. That's easy. World peace. World peace.
What is the one most important thing our society needs?
That would be harsher punishment for parole violators, Stan. And world peace.
So in that short clip, of course, I would be played by Sandra Bullock. So what I mean by that is that we all know that the ideal identifier should be persistent, that the ideal citation should use a persistent identifier so that the ideal data set is fair. But at the end of the day, we all copy paste from the address bar of our browsers. I still do it, we all do it. And the web is not fair. It will most likely never be, but that's just fine. And I'm going to explain during this talk how we can build upon the PID graph and scholarly resources to include less fortunate resources in the whole thing. So PIDs are contracts. They are not silver bullets. First and foremost, persistent is just a matter of service. declaring that an identifier is persistent is not enough. There are billions of documents that will never get DOIs or any other kind of fancy PID. That includes all documents, even though there are a few projects here and there that assign DOIs, for example, to all documents. Gray literature is another example, and the rest of the web. And the rest of the web is pretty big. And then because it's a contract, one part of the contract is for you to mint a PID. The other part of the contract is for me to use the PID when I cite your document, for example. And we know that there are tons of documents with PIDs that are cited with no mention of that PID. A good example being, because we work with Cobaltmetrics, and you've seen that with everything but COVID, newspapers referencing clinical trials or new studies. And most of the time, if you get the name of the journal, that's already like the best citation you'll get from a newspaper. Very rarely do you see DOIs, for example. So just to really, make sure you get my point, I have numbers for you. So last year, we reviewed the whole citation index that we have in Cobaltmetrics. If we take the regular URLs, HTTP, HTTPS, and FTP, that's 98% of the 260 million URLs we had at that time in the citation index. So compact identifiers, and that's not really the same thing as persistent identifiers, but compact identifiers account for only 2% of URIs in our citation index. So given that figure, can we make the PID graphs and the scholarly resources that we have interact with the web at large? Because first, scholarly data is cited in non-scholarly material like newspapers, and also that it is hard to define the boundaries between scholarly and non-scholarly web. And very briefly, when I talk about scientific knowledge graphs, I of course include FREYA's PID graph, Cobaltmetrics knowledge graph, the Open Research Knowledge graph, the research graph, SciGraph, the OpenAir research graph that we're going to hear about in the next presentation, and also Wikidata, which is a good reminder that just like we scientists include non-scholarly resources in our knowledge graphs, there are more generalist resources that do include scholarly information too. And now focusing on Cobaltmetrics and FREYA, the PID graph from FREYA that I assume you've heard about is a graph of scholarly mainly entities, and there are many different relations between these entities, like being the author of or having been published in. In Cobaltmetrics, we have persistent identifiers and non-persistent identifiers that I usually refer to with the umbrella term of URI. So we describe scholarly entities, but not only, and there's only one relation between the entities, which is similar to same as in all, and that means identifies the same resource as, and I have more examples and illustrations to so that you understand. And working with knowledge graphs, it's not very visual. It's hard. Either you show a big graph and you have like a potato of dots on your screen, and it's really hard to understand what's going on, or you take a toy example and then people don't really grasp the complexity of the system. And an analogy that I like is from the Harry Potter series. If you know what the Marauder's map is, or if you don't know, I have an excerpt. So the Marauder's map was a magical document that reveals all of the school of witchcraft and wizardry. It shows every inch of the ground, all the secret passages, and it's also capable of accurately identifying each person. And I think you're getting my point. Being capable of accurately identifying each person is exactly what ORCID does, for example. So if we take that toy example of the graph, which is something you could find in FREYA's PID graph, you have people, contributors, not necessarily the authors, but contributors, institutions that are identified by their grid ID, an API, maybe a sample with the LSID, a data set with the DOI, and then the publication with the DOI. That's what you get from FREYA. What we add with Cobaltmetrics is an extra layer to access those nodes. So for example, we're going to give you HTTP, HTTPS, or FTP URLs that are not persistent, but that we know from trusted sources can be used to enter the graph. So FREYA is going to provide the internal logic, and we're going to give you more access points. So we know everything from FREYA's PID graph. We also know everything from ORCID. We get everything from PubMed. We combine all of that so that you can get more entry points, because maybe you don't have the ORCID, you just have the email address, and you need a new entry point to work that graph. And the extra step with Cobaltmetrics is that we also include dangling URLs, broken URLs, dead URLs, and many other types of less desirable identifiers. So for example, for the institution, you'll have the grid ID, maybe a ROR, and maybe a Ringgold ID, and you'll also get an HTTPS URL that might be dead because it happens in France, for example. Universities get new names, and at some point the old domain is not going to work anymore. Or you're going to be able to use URLs that are more likely to break, like short URLs, for example, on the publication in the corner. So that's really the core of the integration between Cobaltmetrics and FREYA's PID graph, is that you have the PID graph. We don't remove anything, but we add an extra layer on top of it. And that general process of taking one identifier and giving you all the identifiers that identify the same entity, the same resource, that's what we call URI transmutation. And in Cobaltmetrics, we combine many different data sets, many APIs. That includes PID graphs, so PID to PID mappings. For example, the GraphQL API from DataSide that powers the PID graph in FREYA. We have PID to URL resolvers, URL to PID unresolvers, and URL unshorteners to take care of all those pesky short URLs that we all use or that you get automatically from services like Twitter. And so the last point about the Marauder's map in Harry Potter is that the map is not fooled by invisibility cloaks, and even the Hogwarts ghosts were not exempt. So if we rephrase the whole thing, speaking about PID graphs and knowledge graphs, generally speaking, knowledge graphs are magical data structures that reveal all scholarly entities. They show every contributor and every contribution, all the relationships between them, and they're also capable of accurately identifying each entity, for example, ORCID, and they are not fooled by non-persistent identifiers. Even dead URLs are not exempt, and that's the part that you get from Cobaltmetrics. Three really brief examples using the same graph. You can track, so there are many things you can do with a graph. You can start from one node and try to see all the other nodes that you can access from it, or you can have multiple nodes and try to see if there's any relation between the two. So for example, you can start from a publication and get the list of everyone who contributed directly or indirectly to that publication. So you start from the publication, you get to the data set, to the sample, and the staff who produced the sample, for example, would be indirect contributors to that work. Second example, affiliation. You can go both ways. You can find all the people who are affiliated to, or who are or have been affiliated to a given institution, or you can find all the institutions a given person has been affiliated to. Final example. Yep. Derivative works. You can start from a service, an API, like for example, Cobaltmetrics API. Then you're going to find all the data sets that were collected using that service. And then you're going to find all the publications that build upon the data set that were derived from the service. And of course, you can do that with the PID graph. You can do that with most knowledge graph. And Cobaltmetrics adds that layer that I was talking about of all the non-ideal, non-canonical identifiers. A very quick technical note, if you try to get information from the PID graph in Cobaltmetrics right now from the web interface, so by design, aggregators fetch data from many different sources. That's kind of the definition of aggregation. In Cobaltmetrics, when API calls are made, we want to make the data, we want to offer fresh data every time you call the service. At the same time, when you make API calls over short periods of time, we want the responses, meaning the data that you get, to be sensibly comparable, because we keep updating the system and we want to give you some control over at the same time, the freshness and the comparability of the data that you get. So any operation that interacts with third-party servers, for example, the GraphQL API from DataSide that powers the PID graph, every time you contact Cobaltmetrics, it contacts DataSide. And so to make sure that is reproducible, that is turned off by default. And you need to send an extra option to the API, just so you know. But it doesn't change the logic. It doesn't change the capabilities of the whole thing. And And as a conclusion, I'd like to formulate 3 wishes to the FAIRy godparents, because the FAIR data principles are not a silver bullet, and neither are the PIDs, like I said. So first, I think we need to pay off the global fairness debts by assigning PIDs to old research outputs, old objects, old data sets, old publications. We also need to take care of all the existing non-persistent identifiers. Then, because we all have limited time and resources, we need to know where to invest and how much. So we need to be able to measure the ongoing FAIRification of the web, of the scholarly web. But like I said, it's hard to define the limit between scholarly and non-scholarly. So we should at least be able to measure the FAIRification of scholarly and scholarly adjacent resources. And the final thing is that FAIR in all caps does not replace FAIR in lowercase, and we still need, all those conversations about FAIR are really good, but we still need to be talking about algorithmic discrimination, linguistic discrimination, and all the other things we need to improve in the scholarly community. And that's all I have for today. Thank you very much.
Thank you, Luke. So let's move on to our final talk. So Paolo Manghi is going to be talking about the OpenAIRE research graph. So please go ahead.
Okay, let me try to make this thing work, because now I have 2 screens. Can you hear me?
Yes.
Okay. I'm not sure. Imagine to share. Okay, let's see. There it is. Okay. Okay, let me go through. This is the last presentation, so probably you're tired already, so we'll try to make it as smooth as possible for you. Well, I'm Paolo, and I'm the CTO of OpenAIRE, so I'm in charge of the whole service architecture behind it. But first of all, I'm a computer scientist, so we work in the research center. So in short, what OpenAIRE is about. OpenAIRE is being funded now for 10 years. Now it's a legal entity, so it's a no-profit legal entity that works in support of open science in Europe and beyond. We are part of the IOSC, one of the pillars. And we are working on different aspects. Part of these are, of course, the services, which I will talk about today, especially the OpenAIRE resource graph. But we're also working a lot on policies and training with regard to open science. So we have outreach in all European countries and beyond. Again, touching on other continents, trying to align on standard guidelines, practices, workflows, the level of the community as well, so thematic, national and global, as I just mentioned. So what I would like to talk about today is what we do in terms of services. So we are acting at 3 levels: tracking open science, monitoring open science, and discovery mechanisms about open science. Today we'll focus mainly in the center, monitoring, but of course it has to do with the tracking, which is a large chunk of our activities in OpenAIRE. So we are defining together with the communities now in the newborn IOSC guidelines, and trying to align different communities on how to describe and to expose their metadata, reusing standards, of course, not reinventing the wheel, but putting communities at the table and discussing on how to do this. As a result, we have many platforms already implementing part of our guidelines or aligning to them in such a way, let's say, mitigating part of the effort that we have to do to aggregate the data sources we are dealing with. So today I will talk about, as I mentioned, the OpenAIRE resource graph. So what you see here is a view from the moon of the kind of entities, research entities we are dealing with. As you can see, at the center is the research product. We have classified research products in 4 categories, main categories: publications intended for reading and narration. The consumer is a human. Data sets, which are basically data to be processed by algorithms or to be read and interpreted by humans, but still passive, while software is instead intended as code to be interpreted or compiled to become a service or an agent or a process. And other products, where other products are those that are typically digital born under some specific communities, right? So include methods, protocols, or they have their own naming. So the first three classifications, let's say the classes are multidisciplinary, can be easily recognized across different disciplines, while the other research products are including the specific ones. Now, for research products, of course, we include ORCID identifiers, as well as many other kinds of identifiers. We don't make any preference. And we relate to organizations, meaning the organization of an author of a research product, where the connection with the author itself may not necessarily be present. We keep information about the data sources from which we collect, or the data sources that are hosting the research products. So those were from where you can download, in fact, the products. And where possible, we have links to projects, substreams, and funders. This is a very high level view. Of course, the model tends to be a little bit more complex if you go in detail. So what's the idea? The idea is to provide an open metadata research graph. So the graph is completely open, downloadable in DAMs through APIs. Of interlinked scientific products. So we want to have as many links as possible. Even the links may be collected, harvested, and they're part of the metadata in many cases. In several other cases, they are mined, text inferred by us. We would like to make a distinction in the graph between what is open and is not open. And of course, in the end, we would like to link it to funding information, research communities, and organizations. So for that, we want the graph to be open, complete. And by complete, we mean we want to include all trusted sources, so used daily by researchers. We have today 12,000, roughly. We want the graph to be duplicated, and that's because we typically collect the same information about the same entities from different places. We want it to be transparent, so we want to be able to track back to every single source, be it a data source or an algorithm that we use in order to know where the data comes from. We want it to be participatory in the sense that through the guidelines, through several mechanisms, we invite people to offer their data through the data sources, and we want it to be decentralized, meaning that, of course, it's open, you can take it, you can download it, but we also have mechanisms, services that are able to proactively send back to the original sources the information they're interested in and that is not present into their sites. For example, we can send back to Pangea the project links that they don't have, or the open access, non-open access version of an article they don't have, or extra links that we find, etc. Just to name one. Now, just an idea. So we collect from, of course, from other graphs. So from Open Citations, Microsoft Academics, Unpaywall, we have the whole ORCID, the whole data site, Crossref, they're all parts of the graph, as well as thematic repositories, as well as institutional repositories, directories like DOIJ, funders from which we collect. We have 31 funders in beta and 21 in production, from which we collect their related projects. So about 3.5 million, if I'm not mistaken. So we collect all this and map all this into the model that I just mentioned before. Just to give you an idea, the original gateway of aggregation, we collect from 12,000 sources about 400 million products. We harvest close to 1 billion directed links, which are part of the graphs, and we collect 14 million PDFs, from which we extract the full text and we run mining to extract extra links, which are harvested or mined, as you can see there. Especially what is nice and it's interesting is that we reveal links that are not there in the metadata, right? So typically from publications to a project, or from a publication to a data set, and more interestingly, from a publication to a software. So we can identify when a publication mentions a software in a GitHub or a Bitbucket, we have included all possible software repositories out there. When we find a link, we create a respective and related entity in the graph, which is the software, with the metadata we collect from GitHub. We also add the software heritage persistent identifier to the software, and we build the link between the two. So we do the deduplication. The duplication is respectful of provenance. So when two objects are recognized to be the same, for example, two publications from two different data sources, we create one record only that merges all the information that we collect from the original two. So if we have a PMC ID on one side and the DOI on the other side, of course, they will be both present, as well as the original sources, as well as the links they may have to other objects, and become part of one object. And of course, as a consequence, since we keep the provenance, we can send back the information to the original sources saying, you didn't have the PMC ID, but you didn't have the DOI. So if you're interested, I can send you back the information. But we enrich, as I mentioned, through text mining, several other techniques. And we also do propagation, which is not indicated here, but the principle is quite simple. When you have such a graph, you can propagate context from one object to another. Okay, so if I have a publication with a supplemented by relationship to a data set, I can propagate what belongs to the publication to the data set. Examples are author ORCID IDs. If I match the name to a certain level, I can certainly, if it's supplemented by supplementary material, if the authors match to some extent, I can propagate the ORCID identifier. And of course, I can do that for other stuff, other properties, like communities, subjects, all these kind of things can be passed over based on the semantics of the relationships. And remember that every single piece is tracked down based on the underlying logic. So when we provide the full graph, you may exclude from your set of interests the bit of information that you don't think are reliable enough. Okay, every single bean of information that we produce bears a trust level from 0 to 1 and the relative algorithm. So you can, let's say, consider the sub-chunks of the graph that you rely on and you want to play with. So through the APIs, we provide the graph to the outside world. We count about 2 billion accesses per year, and the graph is now available for several services outside, which are using it as part of their production activities daily. And of course, as part of the graph, we have persistent identifiers. We haven't any restrictions on identifiers. We consider all of them. Identifiers are typically included with the schema and the value and the related value. And we here are just some examples of what we have within our system. For funders and projects, it becomes more critical. In fact, for some funders, it's easy to remap also to DOIs. For others, instead, the coding of their projects is not so obvious as it may seem. But in the end, we try to have a service that includes all of these. We will include shortly services as part of the European Open Science Cloud integration and include them as entities in the graph. We have already played with the mining, and it's nice to see that several articles are mentioning services, which today appear in the EOS catalog. So we will be able to rebuild also that part of the story. So complexity is huge when you're building such graphs. Of course, we have a very big infrastructure. We are working, everything is done on big data machinery, large clusters, huge amount of RAM, huge amount of disk, and resources, all in parallel. So we're playing with Spark, of course, because it's the only way to work with such process. And we deal with issues like heterogeneity, quality, and completeness. So several services are dedicated to this. I'm not going through this today because otherwise it gets too extensive. But anyway, the idea is that the resource graph is accessible through open APIs. So if you go to develop.openair.eu, you can already use them and access all the information within the service. We have a portal, which is explore.openair.eu, through which you can access it. We offer APIs, as I mentioned before, to a plethora of different services today. Some are enterprise services like Scopus and SciVal, which use part of our data to produce statistics or to include information on their services. The Commission integrates with our APIs. So when you go and want to report the publications or the data sets that have been produced in a project, you as a project coordinator or somebody on your behalf, of course, you're accessing facts behind the OpenAIRE research graph, and you're able to fetch a preview of the information that we found related with that project. We are working with the United Nations. We are working with several research infrastructures to offer integrated services like monitoring, especially monitoring, because we can customize the kind of mining we do to identify links between our research products in the graph and the different research infrastructures to, let's say, measure the research impact. For example, what we have is all the publications, data, and software that have been produced thanks to the EGI services. Or the same can be said for Instruct, Clarin, some of the mentioned here are using this kind of tools. We can also offer community-specific search and discovery mechanisms, still based on the fact that we can mine, identify data sources that are related with a given discipline, and so on. So portals that are capturing all content in the graph, projects, funders, whatever, related with the community of interest. And of course, we are part of the European Open Science Cloud, where the graph will become the backend of the US resource catalog as a whole. Dumps, we are also offering access to the graph in dumps because it's quite big. So I think it's 200 gigabytes of download. You can access them through the community in Zenodo that we have, that is linked below. And you can access it from different perspectives. So you have the resource graph as a whole, all entities. So you download the set and then you're able to split the different entities together with the links between them. We have specific dumps for COVID-19, where we built a community that is specifically identifying publications, data, software, and projects also related with COVID-19. You can do it, you have a dump related with the communities, so there's a larger set, and that's not just COVID-19. We have DOI Boost. DOI Boost is actually interesting also for your research, is basically the merge of Crossref, ORCID, Microsoft Academics, and Ampeo. So we made a merge and we publish it every 6 months. So you can benefit from this integration. And Scholar Explorer, which is the subset of the graph that bears links between articles and datasets, again, is downloadable. And from December, we'll expose, and this is was already part of the discussion we also had with FREYA, the PID graph that is, of course, a subset of what we have, as we include all these entities as RDF for the world to share and to reuse. As you can see, this is a quite active community behind it, so we receive a lot of feedback, and we would appreciate to have even more. We count more than 3,000 downloads of all these data sets by researchers, but also again by companies who are using it to build their own businesses. And what I've heard today is really interesting. So I think there is a huge margin of collaboration with several of the activities that I've heard about today. With some of you, we already do, even if you don't know, for example, identifiers.org is one of the services that we use to one of the many resolvers we use to resolve the data. It simplifies our lives a lot. With FREYA, there's a clear idea to exchange content. We'll surely feed the skeleton of PIDs that we have with them through this RDF representation. We'll be pleased to do that. And again, we're open for collaboration. So just let us know. The idea in the end is to improve the quality and completeness of this graph, which is to be intended as public good, really. So we like the community to become the owner of the graph, complain about it, but also contribute to make it better and of better quality for the world to use. We would like the graph to be free at the point of use, right? So that's the idea behind. We are now funded by the Commission, by several other projects, but also by interacting with companies. We are very pleased to have in-kind contributions like your skills, for example, your expertise, your will to improve the quality. So we are open to share our mining infrastructures or our mechanisms with you if you have ideas on how to improve things. And let us know. If you want to know more, we are building a dedicated website where we'll include this information and many more. This is very recent. It's since, I think, 15 days, 20 days ago. So many more will come in terms of information. So thank you. If you have any questions, I'll be pleased to answer.
Thank you very much. The talks are finished and we have exactly 10 minutes for a Q&A now. So if anyone has any question, you can go ahead and unmute yourselves or put it into the chat and we can talk about it.
Hi.
Hi, go ahead.
Thanks. I'm Katrina from Hindawi. We're an unfunded partner with FREYA too, but we've been fairly inactive. But one of the things that really interesting set of talks to see where everything's going. One of the things is that there are a lot of APIs out there of different organizations that where they all connected would be an absolute amazing mine to get information regardless of every stakeholder. And some are open, some are partly open, some are not open. And I'm just wondering in terms of whether FREYA has thought about sort of exposing where all those APIs are, how they can be which are open, which are not, because they seem to be, they're the bits, the nuts and bolts that connect all the PIDs and the metadata, essentially, and having a sort of place where you could see what the APIs are, what their scope was, what was in them and what wasn't in them, would be enormously helpful for anyone who wanted to dig in. It's just a thought. I don't know who answers it.
Katrina, may I? It's Paolo here. Can you hear me?
Yes, hi, Paolo.
Okay. So I mentioned it, and also other presenters mentioned that there's a strong collaboration and will to collaborate between all these initiatives, which resulted in an RDA working group, which does exactly that. So we are working basically on ideas and more concretely onto best practices on how these, what we call open science graphs in general, should and could exchange information, right? So we're identifying formats, possibly protocols. For the moment, we're trying to focus on formats that would allow the exchange of information to take place. We did it already in the past with scholix.org, which is a metadata format for the exchange of scholarly links. The idea is to expand on this idea. And so several of these initiatives are already sitting at the table. I can mention the Open Knowledge Research Graph. I see Marcus here, FREYA, of course, OpenAir, and also Severe as well, sitting there, and many others like the Research Graph from Australia. So we have already done some work together. So yes, we are well aware that this would be the way to go.
That's great. It'd be, thanks, you've put the link in the chat.
If I can add to that, I think all the questions about technical limitations and compatibility, data formats, are kind of a red herring, because if you get data in a machine readable way, we'll be able to transform it. Trust the nerds, we'll make it work. But I think we need to be more open about the limitations of the data we collect, and why we collect, with which intent, and which communities we're serving or pretending to serve. And that's harder to document in a way that is machine readable. And if we take the example of Altmetrics, there's that self-reporting table for Altmetrics providers that we are all supposed to release and update. It's something you have to do by hand. And I think if everyone who provides an API around scholarly technology, however you define that, if you support the any point of the scholarly process, we should describe the limitations. I think we need to be more open about the stuff we don't do, more than the formats that and the languages that we picked, which to me are implementation details.
Yeah, no, I think you're right. It's what we're missing as well. But I really like the idea also that you presented of these multiple entry points into different bits of the graph, and I think that came out from all the talks as well, which that's really exciting.
Do we have any other questions?
Well, there is one thing that I've tried to push for a long time, and I discussed this with Martin, with other people sitting here, which would be something like that Catriona was somehow suggesting, but in a different way. So in my dream as a researcher, I would like to have one place, a website or a collection in Zenodo where I go and I find dumps of all these initiatives, data that these initiatives have, published possibly in the same period in order to have it aligned in terms of content, and where I can simply download my material rather than struggling, finding it on different sites, different places. And this would actually be a good sign also of open collaboration, right? So a strong sign of open collaboration. Unfortunately, too often, these initiatives are not opening up properly. Let's say they're not open, but they don't do it in sync or with a strategy. And I think this is something that could be discussed in the future, also as part of this Open Science Graph initiative.
Yeah, I think you got a point there, because it's also kind of the nature of of funding and project proposals, but it's basically scattered all over the place, and every proposal is born in a silo, and if every proposal works in a silo defined by the number of partners that are part of that proposal, maybe it could be a nice thing to have if there was some kind of back communication channel, some kind of back channel or backbone, where even if you are involved in one or many different proposals that are independent, you kind of have that dialogue, that discussion on, okay, we're moving forward these different proposals, but we are also steering these ships into a cohesive, like a coherent destination.
Indeed. And examples can be what we mentioned before, for example, crosswalks or access to explanations on how accessing APIs. So if I remember when I first faced the life sciences, right, and trying to understand what they are in terms of accession numbers, how they relate with each other, the granularity they have, the importance in the citation graph they have, it's impossible to understand and to find all the information in one place, right? And these perceptions can be clarified probably by building this kind of frameworks or places where people can find information in a uniform way, using the same language, with a common understanding of what things are. So I'm definitely up for this kind of initiatives.
Is this something, and I know people don't like the term, that's something like the PID Federation? I'm thinking of both. I know both concepts of sort of where to find stuff in one place, but also the equity issues, which I think are really hugely important that Luke spoke to, and you know, I think one of the aims of the PID Federation is to try and promote equity in that sort of infrastructure space more globally, and whether there's a place there if that takes off.
Yeah, I think it actually falls into what could be the context, or what could be the domain of the concept of federation or PID federation. The problem is the heterogeneous nature of all the different PID resources, and we are already seeing that through the different PID types and how difficult it is to even working at the metadata level to agree on some kind of metadata interoperability or interoperability at metadata level.
Manuel, I think Luke had a point before, so it's true. Metadata and alignment and using common standards is a bit of a red herring. So it's, as long as I have the data, I can find a way through. Of course, you know, the more they're aligned, the better, and that would mitigate the problem. But still, in some cases, you don't have access to the data, or the access to the data is not clear enough. So the APIs are open, but if you have a collection of 500 millions behind the APIs, and you can download only 10,000 at a time, and only by query, then it's a mess to access the whole collection. And in some cases, you would just like to have a dump or a place where I can collect the whole thing and play with it. If we want open science to be transparent and successful, I think this is a minimal case scenario. If you have a collection, you have to make it available, right? Otherwise, there's no way people can reevaluate or verify the quality of your data, in helping you at improving it. And I understand in some cases you are reluctant just because of that, because you don't want to give the data in a way, but it should be done. That's the point, and we're missing this, right? So for us, building this graph has been a huge pain, and keeping it alive, it's a huge pain. There's tens of people working on it, right? And this effort, we just open it up because we know that we don't want others to do it. So in principle, we could give you the original collections that we harvested, not just the end of the process. If this was the case, we'd be happy to share it. But it should be this way since the beginning. And it's not obvious.
Exactly. So there are actually a few points in there. On one side, for having a full interoperability landscape, or having that interoperability or that graph, you need interoperability on two different sides. You need data interoperability, which that's about metadata and all that, and you need operational interoperability. So FAIR is always, it's been all these years about how to actually get the data, but never, or refer or cite the data, but never how to actually access the data. So it's never been on the operational side of things. And I think it's quite interesting that you mentioned the data dumps. Data dumps, offering a data dump in research data resources is incredibly common, because I think it's a kind of twofold consequence. Like, it's a consequence of two different causes. One is the dynamism that is in research. So the research moves fast, and as you mentioned, sometimes you just want to do some experiments or do some playing with some data from a particular data resource, and it may end up not going anywhere else. It may not. It may end up not going farther than that playing, that mangling with the data. But the other factor in the equation is the way those data resources are built. They get funding, they build the data resource, and after that, most of them, they don't even get funding for not even maintaining the resource. So if you need extra features, if you need extra functionality on the data that the data platform is providing, it's actually not possible. So that's the only option, offering a data dump. Okay, this is my data, or whether the data that I can publicly offer, or if I have some kind of access mechanism, just do whatever you want with it. But there's another problem on that, which is that in the future, development iterations on those data resources may actually change that data model, and in some cases make those data dumps disappear. So you don't even have the option of collecting the data dump. And that is, as you said, all those aspects, all those different things together makes it really challenging to actually put everything together and walk through the different data resources.
Those data dumps could be versioned and dumped into Zenodo, so you can always get access to potentially. Anyway,
I just need to interrupt the discussion because we're 5 minutes over, unfortunately. Would you like to conclude your remark, Paolo?
Oh, no, not really. We could go on forever. Just thank you. These are things that can be, of course, further discussed in the RDA group that I just mentioned. We're planning to have a workshop shortly, which will include all the participants, which are many today. So I invite you to register so we can continue there.
Perfect. So I would like to thank everyone for attending, and special thanks to all the speakers. I think we had a very nice session. So thank you, everyone, and enjoy the rest of the talks, and hope to see you around. Okay.
Thank you.
Bye-bye.
Hi.
I'm just asking, will the other presentations, Christina, it's great to see you, and your presentation was incredibly useful too. Will they all be made available somewhere?
Yes, of course.
Oh, where and when?
I will share the link. We have a Zenodo community for the event, and people can, so the speakers are asked to upload them there, and they will also be added to the website.
Great, thanks, Ricardo.
In principle, the best place to go to is the Zenodo community, and I know that some of the presentations of today are already uploaded there.
Oh, great. So, and I'll just find that FREYA Zenodo community.
No, it's actually in the chat now. It's a Zenodo community for this event particularly.
Brilliant. Brilliant. Thanks so much.
Thanks for asking.
All right.
Bye.
See you tomorrow. Bye-bye.
Bye, everyone.